The physics of color, or colored light. The only reason it says iPad at the top here because I had to reformat a few things. You can ignore the word iPad at the top. Anyway, the visible spectrum of light is a small part of the overall spectrum, as we've seen from previous notes. A common acronym that's used is Roy G. Biv, which stands for, quote-unquote, the 7 colors of the rainbow: red, orange, yellow, green, blue, indigo, violet, in that order. It always comes in that order. The red is the low energy and the longer wavelength towards the radio waves. And the blue, or violet, usually we talk about the blue end, which is near the violet, is the higher energy, shorter wavelengths going towards ultraviolet and up towards gamma rays. Alright, so a couple of things that you probably already know, but just to kind of rehash. White light is all the colors. Red, orange, yellow, green, blue, indigo, violet, all mixed together. Now, not all quote-unquote white light is the same. It depends on the mixture. For example, car headlights, you can see at night if you're driving down the road and looking at car headlights, some of them are kind of a bluish white, some are a yellowish white, some are a whiter white. So it depends on the mixture of the 7 colors. Obviously, if you get a lot of blue mixed in with the overall spectrum, it's going to look more like a bluish white. So not all white light is the same, but it's a mixture of these colors. Black, there really is no such thing as black light. Black is the absence of light. That's simply what it is. Opaque objects they appear the color or a mixture of colors of the light that they reflect. Opaque objects are objects in which light does not pass through. It's either absorbed or reflected by that object. For example, though, if you're talking about the color of an opaque object, like grass is an opaque object, light does not travel through grass. It gets absorbed. All colors get absorbed except for green. It reflects green light off the grass into your eyes. Let me go to the next slide here. So there's a picture here showing you how green grass, why it's green. It reflects green light, absorbs red and blue and all the other colors. A lot of times we just talk about the 3 primary colors, which I'll talk about in a few minutes: red, green, and blue, primary colors of light. But the grass is green because it reflects green light. A blue shirt is blue because it reflects blue light off the shirt into your eyes, and so on and so forth. A translucent object, like stained glass, they're objects that pass light through. They're semi-transparent. They appear the color of light that they transmit. This is the second picture I have there. For example, it's red glass. You have red light on top here, green in the middle and blue on the bottom. It doesn't come out in color on your note sheet, obviously, because I don't have a color printer. But the red light, or the red glass here, absorbs the other colors, turns those into heat, and it passes the red light through. So if your eyeball is on the other side, say your eyeball is over here, you're going to see red light coming into your eyes, so you say that the glass is red. It's not reflecting red light, it's passing the red light through from outside into your eyes. Mixing the colors of light. Now there are 7 colors, however we're going to reduce this down to 3 for now, and you'll see hopefully why as we go along here. There are 3 colors that are called the primary colors of light. Red, green, and blue are called the primary colors of light, not paints like you would have in art class. We'll talk about that in a little bit. If you take red light, green light, and blue light, and I'll show you in class with actual lights, when you mix those 3 colors, it will look white. I actually have that example down here. You don't need all 7 colors to make white. Just those 3 colors to our eyes will look white. Now, it turns out that if you take just blue and red light and mix them, you're not going to get white, but what you get is a color called magenta. You see it on the color wheel off here to the left. Now, we're not going to call that mauve or fuchsia or whatever. Don't come up with these other names. We're going to restrict ourselves actually to 6 colors. Red, green, and blue as the primary colors of light, and then the mixtures of any 2 pair of these. For example, if you take red and green light and you mix them, you end up with yellow. Now we can get a little confused here because if you mix red and green paint, you do not get yellow. We'll talk about that in a little bit. But these are mixing lights, not paints. You probably have more experience with mixing paints because that's something easier to do in art class. Very rarely, if ever, have you ever mixed colors of light. So for now, you got to memorize this until you see the demonstration in class. If you take green light and blue light and you mix it together, you get a color what we call cyan. All right. Now on your actual notes, because the notes are a little bit dark, you may need to do something like the following. Like put a little line here and call that R for red, or you want to spell it out, you can. This is green, because the notes are dark, possibly, and this is blue. Or color it in. And then the mixtures are yellow, cyan, and magenta. I guess I'll finish this off. And then in the middle there you have white when all three colors overlap. Another term we're going to refer to is the complementary colors of light. That's when you have two colors of light, then when you add together you get white. For example, if you take blue light plus yellow light, you end up with white light. Because in this class, when we say yellow light, from here on going forward, we're actually saying that what you have are two colors already mixed, the red and green. And when you have cyan light, we're saying in this class that you have blue and green already mixed together. And likewise with magenta, you have red and blue mixed together. So when it comes to the homework and the next test, we're going to limit ourselves to these 6 colors. And if you want to add black and white as 7th and 8th colors, we'll talk about that. But actual colors, there's red, green, and blue, the primary colors of light, and then cyan, magenta, and yellow, which we are going to call the primary pigments or paints. Let me go to the next slide to show you that. Cyan, magenta, and yellow are what we call the primary pigments or primary paints or inks. Now, on the previous slide, those were all colors of light. Now we have paints, and you're probably a little bit more familiar with this. In art class, you may say the primary colors of paint are red, blue, and yellow. Well, it turns out that those are not the best primary pigments or primary colors technically. The best primary colors are cyan, magenta, and yellow. All you got to do is look at an inkjet printer or ink printer, any kind of printer for your computers, and they have these cartridges in them. They have the yellow, the magenta, and the cyan cartridges in their ink, because those are the colors you need to mix as paints or inks to get good quality mixtures of those colors. So let's think about this for a second. And you have a little bit more experience with this, like I've said. Mixing paints. When you mix paints, the result you get when you mix them is darker, as opposed to when you mix lights, like the red, green, and blue, you get something that's whiter. All right, when you mix paints, you get something that's darker. The only 3 combinations of mixtures that we're going to have are these 3 right here, the cyan plus the magenta. If you mix those 2 paints, and really what it is, if you think back to art class, it's really like mixing blue plus red. All right? In a sense, that's in art class that you'd call that, but really in this class it's cyan plus magenta. When you mix those, you really get this nice dark rich blue, the blue color you see on that color wheel in the previous page. In other words, both these paints, cyan paint and magenta paint, both reflect blue to our eyes. That's why you see blue when they're mixed together. They absorb, for example, the yellow, right? Cyan, actually magenta absorbs yellow, and cyan absorbs red. So when you absorb 2 of the 3 primary colors, you end up with the 3rd primary color as the color that that paint looks like. You can memorize this if you want to. And if you look at the color wheel on the previous page or on your notes, you can find some shortcuts on this. So for example, magenta and yellow paint, both of those reflect, I believe, red. because magenta paint would reflect blue and red, yellow would reflect green and red. They both reflect red, so that paint will look red when you mix those two colors of paint. They absorb the green because magenta absorbs green and yellow absorbs blue, does not reflect it. Yellow reflects green and red. So anyway, the common color they reflect is red. That's the color those will look. And finally, then yellow and cyan, when you mix them, they both reflect green, or they will look green when mixed, because they both reflect green. So you can memorize these three combinations. Once again, yellow absorbs blue, and cyan absorbs red. So once again, there's two ways to think about it. You know, what gets absorbed and what gets reflected. They both reflect green, and that's why this looks green. So once again, the colors that we're going to be using in this unit will be the three primary colors of light and the three primary pigments. And then once again, you can add white and black. As far as the answers to the questions that we're going to concern ourselves with, we're not going to be dealing with shades like light green, light blue, sky blue, you know, chartreuse, mauve, you know, all these other shades and fancy colors. We're going to stick with these 6 colors for all the questions we deal with here, partly to keep it simple, but also it's really kind of how inkjet printers work and just the color wheels in general. Let's give you some examples. Well, one more thing to state here. When mixing light, as you've seen, the shortcut is when you're mixing lights, like red light and green light, or red light and blue light, okay, the resulting color of light is one of the primary pigments. The opposite is true when you're mixing the pigments or paints. The resulting paint is the color of one of the primary colors of light. So you can use those shortcuts. Let me give you an example here. Here we have the flag of Chile. This color is blue. On the notes it doesn't look like that. This color is white. And then we have yellow. 3 stripes on the flag of Chile. So what would happen if we shine, well, if we it's those colors because when we shine white light on it, which is what we deal with in everyday life, even light from the sun is white, but once again, it looks like a yellowish white because there's a lot more yellow in the sun's light than there is some of the other colors. But anyway, this flag will only look blue, white, and yellow when you shine white light on it. For example, if you shine red light on this flag, what color will this flag look? Well, let me just kind of outline the flag. Let's say this is the flag. So the flag was, I'll outline it. Whoops. All right, so there's the flag. And now it's going to have 3 stripes. But if I shine red light on this flag, it's not going to look at standard colors under white illumination. For example, if you shine red light on a blue shirt or a blue surface or a blue paint only reflects blue. It does not reflect red. So if you shine red light on the blue portion of that flag, and that's all you have is red light, a good red light, not any other color, that's going to look black. So this part of the flag will look black. All right, the middle part of the flag here is white under normal conditions. It reflects anything that hits it. So if I shine red light on that part of the flag, it's going to reflect that red light. So the middle part will look red, no longer white. It only looks white if you have all the colors hitting it, or at least the 3 primary colors hitting it. So that portion of the flag is going to look red under this condition. And finally, the yellow portion of the flag, and here's where it gets a little bit tough. Yellow paint reflects 2 colors. It reflects red and green. So it will reflect either of those colors if it hits it. And if there's red light hitting the yellow part of the flag, it's only going to reflect red. There's no green present right now. So it turns out that that part of the flag will also look red. So the flag will look like this. It'll look like black, red, red instead of blue, white, yellow. It looks the colors it reflects. The top part reflects nothing. The middle part reflects red. The bottom part reflects red. Let me give you another example. Take that same flag. Repeat the process. Once again, the color it looks, you want to concentrate on what it reflects. So what's available and what it reflects. If I shine magenta, what we got to think about with magenta, once again, is that magenta is two colors of light already mixed. It's blue plus red light. So I'm going to shine blue and red light, magenta, on the blue part of the flag. The blue part of this flag will absorb the red, but it will reflect the blue. So this part of the flag will still look blue like it did before because there's blue light hitting it and reflecting. All right, the middle part of the flag reflects anything that hits it because a white surface under normal conditions will always reflect anything that hits it. And now I have blue and red light hitting it. It's going to reflect both those colors. It will look magenta. Now I don't have a good magenta color here. I'll just write that in here. It's going to be magenta. It's going to look magenta, not blue. And the bottom part of this flag is yellow. Yellow paint, think about it, it reflects red and green. Yellow paint reflects two colors of light, red and green. All right, so what's hitting that yellow portion of the flag here at the bottom? Is green light hitting it? No. Blue, yes, but the blue will be absorbed by that yellow. Yellow does not reflect blue, it absorbs blue, but it does reflect anything red that's hitting it. So it turns out that this bottom portion of the flag, this seems a little bizarre. You don't see this because you need good lights to do this. I'll do some of this in class to show you, but that will be red. That flag will look blue, white, red instead of blue, white, yellow under illumination with magenta light. All right, so the three primary colors of light are red, green, and blue. When you mix them, you get those other combinations, and you get a whiter and whiter light as you go more mixtures. And the primary pigments, or paints, are what we call subtractive because they absorb light and reflect, for example, magenta, yellow, and cyan, the primary pigments, reflect two colors of light each. And that is the physics of color.